and welcome back. Today we are going to be discussing lesson 98 and learning about solving quadratic equations by factoring. So you already are very well aware that we have been talking about quadratic functions and quadratic equations this week. And we have mostly focused on graphing them and learning the characteristics of the graph of a quadratic function, which, as we now know, is a parabola. However, sometimes, as you know, we don't want to graph something in order to do some math with it. You might remember that when we were solving systems of equations, we could solve them by graphing, but that was a little bit tricky and not always super accurate. And so the same thing can apply to quadratic functions. So one of the things that we did in our previous lessons this week was to look at a graph and try to identify where the zeros of the graph fell. And remember that the zeros are the places where the function is equal to 0, or we can think of it as where it crosses the x-axis. So these are zeros because the f of x is equal to 0 here, because remember this is x and this is y, or f of x. So we've already practiced looking at a graph and identifying where those zeros might be, and we were plugging in those points to the quadratic function to test them and see if they really were zeros. But again, sometimes looking at a graph is not always easy. It's not always easy to see where those points actually are, if they're in between some points, or it's just hard to tell on the graph. And so remember that we can, just like when we're solving systems of equations, of linear equations, we can just use math without the graph to do this solving. And the same thing is true with quadratic equations as well. Now, we're not solving systems of quadratic equations. We're just looking at one at a time here, so don't worry. But we're going to move away from looking at the graph to just doing math with it. And remember that a quadratic function could have 2 zeros, 1 0, or 0 zeros. So we've looked at this in a previous lesson, but just as a reminder, we could have a parabola, like I just drew, where we have 2 zeros. So this would be an example of what that graph would look like. Or we could have a parabola that only has 1 0. Maybe it only touches that x-axis in one place. So that would be an example of 1 0. Or we could have a graph that is floating somewhere in one of the quadrants, and then it would have 0 zeros. So again, we've already talked about this, but just to remind you, so as we're solving these quadratic equations, we might have 1 0, 2 zeros, or no zeros. The other property that I want to remind you of is the zero product property. So the zero product property says that if I have two things, they could be variables, they could be numbers, they could be expressions, and they're multiplied together, and I know that they are both equal to 0, or they're equal to 0 when they're multiplied together, then I know that either A has to be equal to 0, or B has to be equal to 0, or both have to be equal to 0. And that just makes sense, right? Because we know that 0 multiplied by a number is always 0. So if I don't know the two things I started with, but I do know they're equal to 0, then one or both of them has to be equal to 0. So this is a little bit of a common sense property. So when we are solving quadratic functions or quadratic equations, we have one important step that we want, or a few important steps. The first one is the most important. And this is set it equal to 0. if it's not already. The second step is always going to be to factor the quadratic. And then the third step is to use that zero product property. So let's see how these steps work out in real life as we're working an example. So we want to solve the quadratic. And this is what we're given. X squared minus 2 is equal to x. So remember, the first step is to set it equal to 0. Now, I can't just throw a 0 in there. It's already set up as an equation. But I can rearrange the terms in this equation so that I have a 0 on one side of the equal sign and everything else on the other side. And remember, whenever we're dealing with quadratics, we always want to have all the terms arranged in standard form. I sound like a broken record with that this week, but it's really important. So if I move this x from this side to the other side, I can subtract an x so that it cancels out here, subtract an x from both sides to keep it balanced. Then I have x squared minus x minus 2. And that's equal to 0 is what I have left. So this is the first step, set it equal to 0 and make sure it's in standard form. So the next step is to factor this quadratic that I have here. And I know that you know how to factor quadratics, and so I'm just going to go ahead and write what it factors as. But you can definitely take the time to do that factoring work. You can move over to the other side of your paper and do that factoring work and then come back to the main problem. And that's still equal to 0. Now, the third step is to use the zero product property. And what does that tell us? Well, I have two things that are multiplied here. I have this part and I have this part. And I know that whatever they are, when they're multiplied together, they're equal to 0. So either the x plus 1 part has to be equal to 0, or the x minus 2 part has to be equal to 0, or both. So what would make x plus 1, that first part, what would make that equal to 0? Well, if I solve for x here, I find that x is equal to negative 1. What about x minus 2? What would make that equal to 0? Again, solving for x, x is equal to 2. So I have two solutions to this quadratic equation. X could be equal to negative 1, or it could be equal to 2. Either one of those, if I plug them in, would work. So that means I have two roots. And remember, anytime we're solving an equation, we can always plug in our answers to our original equation that we're given to check our work. So let's do another example. Find the roots of the equation. And before I even write the equation, let's just stop right there and look at this word roots. So remember in our previous lesson, I told you that especially with quadratics, sometimes we have many different words for the same thing. So remember, we've been calling these solutions, we've called them zeros. And we've also called them solutions, which they are solutions. And here is another word that we can use, and that is roots. And oftentimes, when we're talking about an equation and not a graph, just the equation, we like to use that word roots. So a lot of times you'll see the word roots used when we're talking about just an equation. But they all mean the same thing. If you see a problem that says find the roots of the equation, they want you to solve that equation. And a quadratic equation specifically. So we're given this equation. 3x squared minus 4 is equal to 5x minus 2. So remember, our first step is to set it in standard form, set equal to 0. And so I'm just going to rewrite the equation that I'm given. 3x squared minus 4 is equal to 5x minus 2. So I'm going to start by adding a 2 to both sides so that it's eliminated here on the side it was on originally. So I have 3x squared minus 2. And then I'm going to subtract a 5x from both sides so that it's eliminated over here, and I have negative 5x is equal to 0. But this is not in standard form, is it? So I need to just rearrange my terms. So I have 3x squared, that's in the right spot, but I need to have 5x next, and then the minus 2, and that's equal to 0. So now I've got my standard form, and now I can factor this. And so this factors as 3x plus 1 times x minus 2 is equal to 0. And again, I'm sort of skipping the work for that factoring step. But when you're doing your homework, you will take the time to do that factoring work. We're just focusing on the solving part for this lesson since I know that you know how to factor. And if you get stuck on the factoring, just ask me. So now I need to think about what would it take to make each of these parts equal to 0. So sometimes it's helpful to write it out this way and just go through the solving steps. So subtract 1 from both sides, and then I need to divide both sides by 3, so x could be equal to negative 1/3. Or if we look at the other term, x minus 2, add 2 to both sides, x could be equal to 2. So I have two solutions here as well. So x could be equal to negative 1/3 and x could be equal to 2. And we need both numbers in order to have the whole answer for the problem. We cannot just give one number and say, oh, that would work, that's good enough. We need to have all the possible answers, otherwise the answer is incomplete, unfortunately. Let's do another example just to finish up this discussion. So we want to find the roots. So there's that word again, roots. And this is what we want to find the roots of. 9x squared is equal to 27x. So I need to first put it into standard form, right? And so I'm just going to rewrite the equation first, the equation as I'm given, and it needs to be in standard form with the other side equal to 0. So I'm going to subtract 27x from both sides because I don't want it over here. So then I have 9x squared minus 27x is equal to 0. So now I'm in standard form and I'm equal to 0. Now notice that I do not have a constant term part. But that's okay. Sometimes we don't have a constant term as long as, or maybe even an x term. As long as everything is in descending order and we have that x squared term there, we know that we're okay. So the second step is to factor. Now you might be thinking, how do I factor this if it's not a trinomial with 3 terms? I don't know how to factor it back into that sort of FOIL form with the 2 binomials. But remember that we have other ways of factoring. And I look at the terms that I have, and I see that 9x is a common factor in both terms. So if I factor out a 9x, then for the first term, I'm left with just x, and for the second term, I'm left with a minus 3. And that's still equal to 0. And I still can use my zero product property here, because I have this term, 9 times x, and it's multiplied by this term, x minus 3. So if 9x was to be equal to 0, which is one of the possibilities, then x would have to be equal to 0. If x minus 3 was equal to 0, I would add a 3 to both sides, and x would have to be equal to 3. So these are my two roots. X is equal to 0, and x is equal to 3. And you can write it either way. You can leave them separate and box them both in separately, or you can kind of combine them together in a list with a comma that way. Either way is a valid way to write your answer, in case you're wondering. And that is it for this lesson, and I'll see you next time.